So in this problem, we have a gymnast that's bouncing on a trampoline. On the upward part of the motion, the mat of the trampoline pushes on the gymnast over a distance of 0.300 meters. Then the gymnast leaves the mat and goes up into the air for an additional 2 meters. What average force does the mat exert on the gymnast? And it is, if I make a picture here, I'm going to have, here is the trampoline when it's stretched, and here's the person when they're down there, and then later on they're going to be up there. So there's the person on the trampoline. The only time that the work is acting on the gymnast is from there until the stretched trampoline comes back to its neutral position. That's when work is happening on this person. So my starting position is when it's fully stretched, and my finishing position is when the person reaches their maximum height up in the air. Also note that they said average force. And the average force is the only thing that we can solve for because it's not a constant force from there to there. When the mat is fully stretched, there's a greater force acting on this person than as it goes closer and closer to its neutral position. When the mat is now level, it will be zero. There'll be zero force. Okay, because we're getting the work on the gymnast from the elastic potential energy that's in the mat. So when the mat is stretched, there's elastic potential energy. That elastic potential energy is what does the work on the gymnast. And our equation is for the gymnast. So my next step is to write KO plus UO plus W equals KF plus UF. Now, I've had some people do this problem where they break it into two parts. They will actually solve the problem from the time that the gymnast is fully stretching the mat until the time that they leave the mat. They figure out what their velocity is here. And then once they know that, then they figure out how high they're going to go from there. But I'm not going to do that. I'm starting here and I'm ending there. So if I'm starting here, what can I say over here is 0? Which of these variables is 0? What? UO is 0. What else is 0? What's the speed of the gymnast when it's fully stretched? 0, because they were going down, 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 down. They stop, and then they start coming up. So there's a moment where we change from going down to going up, and that's when they're stopped at the full stretch of the mat. So that means that this is also 0. What else is 0 in this problem? KF, because when they go up into the air, same thing down here. When they go up in the air, they're going up, 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 up. They reach their maximum height, then they start coming down. So in between going up and coming down, they have to stop. So the final kinetic energy is 0. So there's my equation, work equals UF. And so in this problem, since we are looking for the average force from the mat, I am going to replace work with FD. Because they're not giving me the work and they're not asking for the work. They're actually asking for the average force exerted on the gymnast. And UF is going to be mg times the final height. Now the math here is really easy because F is the unknown, so I just have to divide both sides by D. mg times the final height divided by D. So I'm going to have mgh divided by D. In this problem, the gymnast had a mass of 55 kilograms. Gravity is always 9.8 meters per second squared on Earth. That's the number we use. And now what should I write down for the height in this problem? So the mat is stretched 0.3 meters, and then the person is going to go up into the air an additional 2 meters above the mat. So what should I have for my final height? 2.3. Because between there and there is 0.3, and between there and there is 2.0. So between there and there is 2.3. So 2.3 meters. And what distance was the force applied? Over what distance? 0.3. Okay, the force was only applied over the first 0.300 meters of the motion, of the gymnast movement from its low point to its high point. So if you solve this, this is going to give you the average force. And the average force for that was 4,132 newtons. What that tells me is that at the fully compressed mat, when the gymnast was fully compressing the mat, this number was actually 8,264 right there. Like at that moment in time, it would be 8,264, and then it loses it, and when it gets back, when it's moved 0.3 meters up, it will be 0. So the average between 0 and 8,264 is 4,132, because that's the average force. All right? So now that I have that answer, let's see how much time I have. Okay, let's say I wanted to figure out what was the speed of the gymnast when they left the mat. So I'm going to do this in a different color, and I'll do it over here. So I'm going to begin with KO plus UO plus W equals KF plus UF. But now I'm going to do it for the time period between when they were there and when they leave the mat. So from there to there. And I want to solve for the velocity that that person leaves the mat at. So if I'm doing that, what can I make equal to 0 in my equation? KO is still 0. UO is still 0. And that's it, right? Because actually when they come off the mat, they're going to come off the mat with a speed, and they're going to be higher than they were to begin with. So there's my equation now. So I already know what the work is. I just solved it. So we'll replace work with F times D. And then we're going to get 1/2 mvf squared plus mg times the final height, which is a different number than what we had when we first solved it, because with this person, the final height is a much smaller distance above where they started from when they left the mat. So if I want to solve for VF, well, the next thing I would do, VF is my unknown, because I want to know what speed does the gymnast leave the mat at. So I'm going to multiply the thing by 2. I'm going to get 2FD equals mVF squared plus 2mg times the final height. Since my unknown is VF, I'm going to take this. Well, this is already on the side. So I'm going to take this and move it over, divide by m, and take the square root. So when all of that is done, my final velocity is going to equal 2FD, okay, because that's already on that side. Now I'm going to move this term over, so it's going to be minus 2mg times the final height, and that's going to be divided by m. Now that would equal VF squared. So we take the square root to get the VF. And if we solve all of this, we're going to get 2FD minus 2mgh, all divided by M. So for the force, we just got that answer, 4132 newtons. What's the distance? What do I put in for the distance for this? 0.3. So 0.300 meters. The mass was 55 kilograms, which I can put there and also down here. The G is 9.8 meters per second squared. And what do I put for the height, the final height? Say that again? No. No. Look, it's ending. The motion begins here and ends there. Because we're talking about what's the speed that they leave the mat at. So how much higher is this than that? 0.3. So it's both the D and the final height. 0.300 meters. And as far as units, I will get meters per second. I mean, this one's kilogram meters per second. Well, this one is a kilogram meter per second squared. But let's just look over here. The kilogram would cancel the kilogram, and I get meters squared per second squared under a square root. So that's why you put your units when you substitute, because you have to show me why the number is what it is and why the unit is what it is. And if you solve this, what do you get for the answer for the velocity? I think the other class said it was like 6.2 something, 6.26. 6.26 meters per second. So that is the speed that the gymnast leaves the mat at. So I could now do a third part. I don't have time looking at the video length that I'm at where I am now. But what I could then do is begin my motion right here when they leave the mat to figure out how high they're going to go up in the air. Now, I already know that number's 2 meters, but I could just check it using the 6.26 meters per second as my original velocity, meaning it would now be my original kinetic energy. Okay, so it was down here, this is final velocity. So this is final velocity for this part of the problem, but if I then wanted to solve for how high the person goes up in the air from the point that they leave the mat, it would now be, that would represent the original velocity. And also what variable in which one of these variables, if I did that, which one of these would now be 0 that was not 0 in the other two parts? Which one of these will now be 0 if I now solve the problem from the time that the person leaves the mat until they go up into the air? Which one of these is now 0? Work, because the work already happened. And that's what gave it a original kinetic energy. All right, any questions with that?